Good afternoon, teacher. We are Group 11, and our group member have Eric Lau, Chiu Ziyan, Li Junhao, and me, Leong Yuxuan, and Wong Chujun. Now I'll be talking about the introduction. So our company is a clothing company which located in Kuala Lumpur. The company has their own brand called Unknown, which is very famous in Malaysia. The company has two floors. In floor 1, there are 5 servers, 2 printers, 1 router, 1 access point, 1 switch, and 1 main switch. In floor 2, there are 1 waiting room, 1 shooting room, 1 live streaming room, boss office, a printing area, toilet for men and women, 1 design room, 1 meeting room, 2 working area, a reception counter, and a pantry. So for floor 1, we have 24 hosts, and for floor 2, we have 92 hosts. So for floor plan 1, floor plan 1 is designed with a different functional area to optimize both network efficiency and workspace productivity. The server room, the occupied on the upper section, is dedicated to important network components like 2 switch, 1 main switch, and floor 1 switch, a central router, and 5 server rack, and 2 printers. So this configuration simplify the management, maintenance, and future growth by centralizing necessary components. The arrangement reduces the possible network clutter and interruption by separating these components from the primary workspace to allow staff members to concentrate on their work. So the bottom section of the floor plan is designed as the primary workspace area, featuring with the 6 desks and an access point to provide the wireless connectivity. By providing a specific area for keeping important document or doing administrative tasks with a security lock to improve the arrangement even further, and also the lift and stairs easier to go upstairs. This partition of space keep things organized and secure while giving employees the flexibility and network connectivity they require. So there are 62 hosts in floor 1 as the subnet mask is 255.255.255.192. With 6 bits available for host addresses, the total number of the possible combination is 2 times 6, equal to 64. However, in each subnet, 2 addresses are reserved, 1 for the network address and 1 for the broadcast address. As a result, the number of usable host addresses is 64 minus 2 equal to 62. So the floor plan 2 is designed to enhance the both functionality and efficiency, catering to various office activities. The area is split up to multiple important sections, and there's 2 primary for work are labeled as the working area 1 and working area 2. And these areas are arranged to provide easy access to different office areas, enabling the efficient communication and teamwork among the employees. The boss office is located next to this workplace, so enable the seamless interaction with employees. To support the operation, the floor plan including a shooting room for video production, 2 live streaming room for broadcasting in an enclosed space, and a design room is for creative and collaborative work. The common area like meeting rooms is provide a specific area for group discussion and presentation, and waiting rooms give guests a comfortable space to wait. The employee can prepare and eat food in the pantry, which acts as a small cooking area. The layout of the floor plan, including the men and women toilets, they are located conveniently on the right side of the vertical transportation, alternative like stairs and lift that makes it easier to go between the floor. The office has well-integrated network infrastructure, 2 switches, floor 2 switch 1 and floor 2 switch 2 are part of the layout and are arranged to effectively control the network traffic. To provide a reliable, strong wireless connectivity, numerous access points are strategically placed across the office. Specifically, access point 2 is near the shooting area, and access point 3 is in the center of working area. Access point 4 is close to the boss office, and access point 5 is near to the design room. A printer is also positioned in an area that is conveniently accessible from many workspaces. There are 186 hosts in the floor 2, as there are 3 subnets each, having a subnet mask of 255.255.255.192. The total usable hosts equal to 62, divided the subnet, multiple 3 subnets equal to 186 hosts.
Okay, so I will explain about the selection of our topology. So for a local area network, we choose to use a star topology because it could be one in which each node is directly connected to a hub or a switch, like a central connecting point. So a star topology requires more cables than a bus, but it has the advantage that just one node will be affected if a cable fails. So a hub is a central device that is connected to every device in the network, and when a device sends information to another device, it sends the information to the hub first, and then the hub will forward it to all the appropriate devices. So in the star topology, n links are needed to connect each node, where n is the total number of nodes. All the network functions are managed and controlled by the hub, switch, or a concentrator. So as we know, every node in a star topology is connected to the hub and the central hub that facilitates the data transfer in star topology. When a node wants to transmit the data to another node, it will send the data to the central node first, then only distribute it to other nodes on the network. So when the node receives the data, it checks for the destination address, and if the address matches, then only the data will be accepted. Otherwise, the data will be refused or rejected. So for our network, we decided on star topology because it brings a lot of benefits to our network. It provides excellent reliability, and also to ensure that the network will continue to function even if in the case of a single cable or a device failure. By reducing the data clashes, it design improves network performance overall. Since each device only needs 1 I/O port and 1 connection to the switch, it is also simple. Considering that every connection in the star topology is clearly identified, it is also robust, simple to install, and also makes the finding problems easier. It is a very scalable and adaptable option for our network configuration because adding or deleting the devices doesn't disrupt it.
So this will be the justification of topology of our network diagram. The above diagram displays the network diagram for the first and second floor of our office. As for floor 1, in total there are 23 23 used and reserved hosts in VLAN 10. There are 8 that is in use, which include 5 servers, 2 printers, and 1 PC. However, there are 15 hosts reserved for extra use in the future, 10 for server room and 5 for printing area 1. The network ID for the server room is from 192.168.10.11-15, and printing area is from 192.168.10.16-18. The range of valid hosts in VLAN 10 is from 192.168.10.1 to 192.168.10.62. As for the second floor, there are 48 total use and reserved hosts in VLAN 20. There are 18 hosts used, which includes 16 PCs in the working area 1, 1 PC at the information counter, and 1 PC in the boss office. In total, there are 30 reserved hosts for extra use, 20 in the working area 1, 5 at the information counter, and 5 for the boss office. The network ID used for working area 1 is from 192.168.20.21-36. Information counter is only 192.168.20.19, and boss office is 192.168.20.20. The range of valid hosts in VLAN 20 is from 92.168.20.1 to 192.168.20.62. VLAN 30 is for working area 3. It has a total of 18 use and reserved hosts, 8 use and 10 reserved. There are 8 use hosts, which include 8 working PCs in that area. The network ID used for VLAN 30 is from 192.168.30.37-44, and the range of valid hosts VLAN 30 is from 192.168.30.1 to 192.168.301.62.
So lastly, for VLAN 40 and second floor, there is a total of 26 users and reserved hosts, 11 users and 15 reserved hosts respectively. And the use host includes 10 PCs in working area 2 and 1 printer at the printing area 2. The network ID in use is from 192.168.40.51/60 at working area 2 and 192.168.40.61 for printing area 2. The valid host range for VLAN 40 is from 192.168.40.1 to 192.168.40.62. So in summary, each host in floor 1 is connected to the floor 1 switch, and each host in the VLAN 20 is in floor 2 is connected to the floor 2 switch 1, and each host in VLAN 30 and 40 is connected to the floor 2 switch 2. Floor 1 switch, floor 2 switch 1, and floor 2 switch 2 are connected to the main switch. To connect to the main switch, floor 1 switch 1 uses IP address of 192.168.10.1, and floor 2 switch 1 uses IP address of 192.168.20.1, and floor 2 switch 2 uses 192.168.1.30.1 and 192.168.40.1. So the router is then connected to the main switch that is beside it for the internet access using the IP address of 192.168.1.2. So the subnet mask for both floors uses 255.255.255.192, as this allows all devices to be able to communicate with each other. So we choose 255.255.255.192 because it gives us 4 networks of 62 hosts each, which is sufficient for our use. So this is a host table for VLAN 10, and this is a host table for VLAN 20, 30, and 40.
Okay, so now I'll be presenting on the ENSP for our OSCN assignment. And this is our internet service provider connecting to router, connecting to the main switch, connecting to the subswitch, and connecting to the device on it. And now I will show how the main switch will connect a pin to the floor 1 switch. The floor 1 switch is 192.168.10.1, and ensure that it successfully pinned. And apart from that, I will also pin to the floor 2 switch 1, which the IP address is 192.168.20.1, and it will also show. Okay, then I will show the switch that can pin to the device in it. For the PC1, the address is 192.168.20.21. So 20.21. And ensure that it can be successfully pinned. And next, I will continue with internal pin. Devices in the same VLAN. I will pin PC3 to PC1. And 20.21. And ensure that it also successfully pinned. And lastly, I will show how to pin the PC in different VLAN, for example, VLAN 30 and VLAN 40, how to pin to each other. For example, this PC 17, the IP address is 192.168.30.33, and this one is 192.168.40.51. This one is in VLAN 40, and this one is in VLAN 30. And I try to pin from PC 26 to PC 17. 177. Okay, and ensure that it also successfully pinned. And that's all for my presentation for the ENSP part for the OSCN. Thank you.
Okay. So in conclusion, our standard network topology supports our medium-sized business with seamless wire and wireless connectivity. Using Huawei ENSP tools, we design an efficient IP addressing scheme and subnetting for enhanced performance. Tailored solutions provide secure management access on the first floor and broad connectivity on the second, supporting essential service and improving internal communication. And lastly, the scalable design future-proofs the network, ensuring it evolves with technological advancement, and this project demonstrates our ability to solve complex network challenges, enhancing productivity and reliability. Thank you.